All right. So today I just want to go over the mock final and see if there is any specific questions or just solve them one by one so that people will have an idea of what to expect in the final exam. Now, I hope you have seen this on Canvas that I posted a file like the final exam mock, which shows that the exam is going to be 2 hours, 5 problems. It is use of calculator or software, Excel, MATLAB, everything is allowed, open book or notes. And you need to use additional sheets to record your responses, and that is the only thing we will be collecting. So we won't see your Excel or MATLAB. So make sure that you document everything on the sheet. Only that will be graded. There will be 5 problems covering these specific topics that I've shortlisted so that if you study these, you should be good. Any of these problems could be a word problem involving some physics or engineering, or it could be just a math problem saying solve this using a particular method. During the exam, you can do all your work on the calculator and paper, or you can use Excel, MATLAB, whatever you want to use. You can bring any prepared Excel sheets or codes that you can use during the exam. All that is fine, but make sure you record all the details in your sheet, because we will not be collecting anything other than the paper. Okay, so if you have something that you had written down but is not included in what you gave us, it won't be graded. That's it. So with that, I'll just jump into the problems that the 5 problems. Problem 1 is going to be either like it'll be solving a nonlinear equation, either using Newton-Raphson method or bisection method. Only these 2 methods, so you need to practice both. You won't know which one is going to appear, so you should know both methods at least. And this problem here, sample problem here, I've given f of x equal to this function. Solve for f of x using Newton-Raphson method with this initial guess. Perform iterations until the value of the function goes below 0.001 and fill out this table. Essentially, your final response is this table. But of course, the work also has to be shown how you got these numbers. You can't just directly fill this table. You have to say how or go through the steps. Okay, so let's do this together. Okay, so I'm going to stop sharing this screen and show you my PowerPoint. So hopefully you can see my PowerPoint. And now let me start writing this down. So what is your function? The function is f of x equal to minus 2x power 6 minus 1.5x to the 4th plus 10x plus 2. So that is your function. And we are asked to solve for f of x equal to 0. Solve for f of x equal to 0. And with the Newton-Raphson method, you always need an initial guess, which is given to you as x0 equal to 0, x0 equal to 1.5. That's what is given to us. So what is the method? The method is xi plus 1 is xi minus f of xi divided by f dash of xi. That is the Newton-Raphson method. So in the table, you are already given like the initial guess. Okay, so let me write out the table. Iteration I, xi, f of xi, f dash of xi, and then xi plus 1, and then f of xi plus 1. That is the table given to us. Initial guess is asked to be used as 1.5. So what do you do first? Step 1 is calculate. Actually, first the calculate f of 1.5. What is f of 1.5? That is equal to minus 2 times 1.5 to the power 6 minus 1.5 times 1.5 to the power 4 plus 10 times 1.5 plus 2. It's simple enough. I'm just trying to do this so that it will be easy for people who are following it later. You can put it in your calculator and we'll know what the number is. Have it here. So that will be, just 1 second. Yeah, so that will be, do you have the number, Andrea?
I'll put it in my calculator.
You're working on it?
Yes, I'm putting it in my calculator.
Okay. So check if you are getting minus 13.375.
Yeah, that's what I got.
Okay. So then f dashed of x, what is f dashed of x? That will be minus 12x to the 5 minus 1.5 times 4, which is 6x cubed plus 10. So if you want to get f dashed of 1.5, that will be minus 12, 1.5 to the 5th minus 6 times 1.5 cubed plus 10, which if you again punch it in your calculator, you should be getting minus 101.375. So these two are important numbers because, so this number is minus 13.375 minus 101.375. So xi plus 1 would be xi, which is 1.5 minus f of xi, which is minus 13.375 divided by f dashed of xi, which is minus 101.375. So you need to put that into your calculator, work it out, and to save time, I'm just going to keep telling the numbers because it's only one student right now. 1.3681. 1.3681. So from 1.5, the initial guess, the value has been updated to 1.3681. So let's keep working out how much it will change. So I'm going to take my Word file, fill out these numbers so that I can put it later on the web. Minus 13.375 minus 101.375, then 1.3681. And what is the value of the function at this 1.3681? That is the last column. If you do the calculation, it will come out to be minus 2.6857. Minus 2.6857. Okay. See, your goal ultimately is to figure out what value of x will make this approximately 0. That is the goal. So you have to keep watching this last column and you have to keep doing this until the last column falls below 0.001. That's the goal. Okay. All right. So then that is iteration. That is initial guess. After the initial guess, you have done, you have gotten a value of 1.3681. So this becomes I equal to 1. So then the next row, what you do is I f I x I f of xi f dashed of xi xi plus 1 f of xi plus 1. That's the sequence. So we have 0, 1.5, 1, 1.3681. So this number directly comes over here. Now you have to go through these values of what is f of x, what is f dash of x, what is xi plus 1. You do that, f of xi value that is this value here. If you use this as your x, f of xi value will come out to be minus 2.6859. Always maintain 4 decimal points. And the value of the derivative is 62.8689. And the value of the function is 1.3254. And that is the value of xi plus 1. And the value of the function is minus 2.2141. Okay, I'm going to share my screen here. I've been typing this on my Word file. That's why it didn't update on the screen. So those are the values. So what we want to see is we have to keep doing this iteration, perform iterations until the value of the function goes below 0.001. That is the goal. So now this number has to come here. That's the next iteration. And now you have to evaluate what is the value of the function, which is this. So this is simply minus 0.2141. And then what is f dash of x? F dash of x value is minus 53.0393. And then what is xi plus 1? That is 1.3213. And the value of the function is minus 0.00117, or actually 18. So you can see here that this function is getting closer and closer to 0. It's still above 0.001. That is until its absolute value is above 0.001. So then you do the next iteration. This number carries over. Okay, so this is minus 0.0018. What is the value of the derivative? I'm going this fast because I have all the values ready. I'm just trying to show the method and then hopefully cover all the problems. 1694. And xi plus 1 is 1.3213. And the value of the function is, I'm rounding it off to 4 decimal points. Actually, it has more decimal points here. So it comes out to minus 1.2 times 10 power minus 7. That is, if I write this to 6 decimal points, this is 064. This is 345. This is 1309. This is 13 or 1275. So here, this number has gone below 0. I'm sorry, it's below absolute value is below 0.001. So you may stop. So what is required is fill out this table, and to do this calculation, you can show this like one line. You can show how you got each number, and then you don't have to do the same for every line. You can just say that you can just fill out the numbers and it will make sense. So if you show me once, I understand how you got it, then you can fill out this table. That makes sense?
It is.
Okay. So I have this solution updated now, which is good. I can later post it. Okay. So then let's move on to the next problem. So you're having a problem from regression. Fit a second order polynomial of the form a0 plus a1x plus a2x squared using least squared method for the table below. All the steps of doing the least square regression method must clearly be shown. Producing only the final answer is not enough. After showing the steps, fill out this table for a0, a1 and a2 values. Very simple. Okay. So let me go back to my PowerPoint. Okay. So how do you start this problem? So problem two, you have the x data, xi and yi. So you are required to fit y equal to a0 plus a1x plus a2x squared. This is what is required. So I don't want to go into the entire details of least squared method, but what is required is least squares regression involves setting up three linear equations for a0, a1, a2 with coefficients derived using the given data. How do you do that? So you have this, here's a neat trick, okay? Y equal to a0 plus a1x plus a2x squared. It's given to you. So what you do is this. Sigma yi equal to a0 n plus a1 sigma xi plus a2 sigma xi squared. Sigma xi yi is a0 sigma xi plus a1 sigma xi. It's almost like multiplying by x throughout. Okay, like, not exactly like, xi cube. Sigma xi squared yi equal to a0 sigma xi yi plus a1 sigma xi squared yi plus a2 sigma, I'm sorry, this is squared, this is cubed, this is to the fourth. So all these numbers, there is the summations have to come from the table. All these numbers have to come from the table. So if you get 3 plus 3, 6 plus 2, 8 numbers from the table, you just have to put them here and then treat this like a system of linear equations and solve them for a0, a1, a2. If nothing is given about what method to use for the linear equations, you can use any method that you want, like Gauss elimination, Kramer's rule, Gauss-Seidel method, whatever you want to do, that's fine. So now, if you go back here, this is given to you. These two are given to you. You can always square it, cube it, take to the fourth power, multiply by y, multiplied the squared by y, multiply the, I think it's just up to x squared y. Yeah, you don't need to go further. So you can get all these numbers from the original data and then get their summation and then go for the final answer. Okay. Is it making sense so far?
Yeah.
Okay. So I'm going to show my Excel file, and I'm going to use my Excel file to enter these numbers and then try to get the answer. That is, use Excel to. So this is X, Y. If I'm doing this in the exam, this is exactly what I would do. Okay, 0.5, 700, 0.8, 1000, 1.2, 1200, 1.7, 2200, 2.0, 2650, 2.3, 3750. So I want x squared, x cubed, x to the fourth, xy, x squared times y. Straightforward, square it, cube it, raise it to the fourth power, multiply x and y, square the x, and then multiply by the y. So very easy. Drag it down and then do summation, sum. I'll also write count how many rows are here. That is my n. So this is my n value, and this is all the sigmas. Okay. I mean, I also need this. So that is 4 plus 3, 7 plus 1, 8 numbers that I previously identified. Now I'm going to take all those and put it in my PowerPoint file. You can also do the same. And I'm going to form 3 equations in 3 unknowns. So what is the first equation? Sigma yi equal to a naught n plus a1 sigma xi plus a2 sigma xi squared. What is sigma y? Sigma y is 12,000 equal to, that is sigma y, 12,000. A naught n is 7, so that is 7 a naught plus a1. What is a1? a1 times sigma xi. Sigma xi is 8.7. 8.7 a1 plus xi squared, that is 14.55 a2. Okay. What is the second equation? Sigma xi yi equal to a naught sigma xi plus a1 sigma xi squared plus a2 sigma xi cube. What is sigma xy? 20,355 equal to a naught times, what is sigma x? That is here, 8.7 times a naught plus, what is sigma xi squared? 14.55 times a1 plus, what is sigma xi cubed? That's 27.453 a2. So that's the second equation. I mean, I'll show you all the 3 equations shortly. Third equation, sigma x squared yi equal to a naught sigma xi squared plus a1 sigma xi cube plus a2 sigma xi to the fourth. What is x squared y? That is this number, 39,358.5 equal to sigma xi squared, which is 14.55 times a naught plus xi cube, which is 27.453 a1 plus x to the fourth, which is 54.8835 A2. So I'm going to bring back my PowerPoint screen so that you can see all this in one place. All right. So here's the first equation. Okay. Here's the first equation. Here's the second equation. And here's the third equation. So you need to solve for A0, A1, A2. Not that complicated. You can easily do that. What I'm going to do is quickly tell you the answer that you can check against later. All right, so if you solve, actually A0 should be equal to 604.09. A1 is equal to minus 233.96. A2 is 674.01. So I'll enter this in my Word file. A0 is 604.09 minus 233.96 and then 674.01. All right. With me? So far? Yes.
Everything's good.
Okay, good. So then let's